Hello everyone, welcome to Miss Lee's class. Today we're going to learn properties of linear relations. So we're going to learn how to identify linear relations. Right. So look at the warm-up question. Complete the charts and answer the questions. So I have in your lesson notes, if the lines are not visible, I want you to draw it again like this. Okay, so we're going to fill out two charts. First, width of the rectangle. This is the width of the rectangle. 1, 2, 3, 4. And we're gonna find the area of the rectangle. So 1 times 2 is 2. 2 times 3 is 6. 3 times 4 is 12. 4 times 5 is 20. So the area of the rectangle is 2, 6, 12, 20. And here, width of the rectangle 1, 2, 3, 4, and perimeter of the rectangle. What's perimeter of the rectangle, everyone? The length around the rectangle is the perimeter of the rectangle. So the first one, 2, 2, 1, 1. You have to add them up. 2 plus 2 plus 1 plus 1, which is 6. Right? 6 here. 2, 2, 2, 3, 3. 3 plus 3 plus 2 plus 2 is 10. 3, 3, 4, 4. 4 plus 4 plus 3 plus 3, which is 14. 4, 4, 5, 5. So 4 plus 4 plus 4 plus 5 plus 5, which is 18. So write that down. And we're going to compare those two to find the linear relations. So we actually learned the linear relation last year. To become a linear relation, what we have to look at is change in the first variable. So this is increased by 1. And change in the second variable. This is increased by 4, 6, 8. The rate of change should be constant. But when the first variable, width of rectangle, is increased by 1, the area is increased by 4, but this is increased by 1, but next one is increased by 6. It's not really constant. So this is not a linear relation. But if you look at this, every time the width of rectangle is increased by 1, perimeter is increased by 4. Constant rate of change. Therefore, this is a linear relation. Okay? So we say width versus perimeter is a linear relation because constant rate of change in both variable. So write that down. Okay, and write an equation that can be used to determine the perimeter. Okay, everyone? Every time the width of the rectangle is increased by 1, the perimeter is increased by 4. So what we're going to write is perimeter. Let's say perimeter, P for perimeter, and W for the width. So we want to know the perimeters, right? Perimeter is, because this is increased by 4, 4 times W plus something. Okay, so I want you to remember this form. So it always starts with P equals It always starts with P, and you write 4 here. So you write P first, and you write 4 here, and you write W here. Okay, P 4 times W, remember, multiplication is hiding here. And you have to add something here. You're going to figure this number out. Okay, if the width is 1, then it becomes 4 times 1. Plus something is perimeter, which is 6. Right? So plus something is perimeter, which is 6. What number do I need to add here to make 6? That's 2. Is that right? Okay, let's test if it works for 2. So if you look at the second line, when width is 2, the perimeter should be 10. Let's see if it works. Plug 2 into W. Then 4 times 2 is 8 plus 2. Then 8 plus 2 is 10. So this equation actually works, right? So here, this is the equation for this linear relation. Okay, let's move on. For a linear relation, a constant change in independent variable results in constant change in dependent variable. So everyone, what's independent variable and dependent variable? So independent variable is the variable that does not depend on any variable. So for example, here, if you look at the width does not depend on any variable, but perimeter changes depending on the width. Perimeter changes, right? If the width is 1, perimeter becomes a 6. And if the width is 2, perimeter becomes 10. So width of the rectangle is independent variable, and perimeter is dependent variable, because depending on the width, the perimeter changes, right? So linear relation. To become a linear relation, constant change in both variables, both independent and dependent variable. So that's called linear relation. Constant change is really important to become a linear relation. Okay. So linear relation. So when you graph a linear relation, it is a straight line. That's why we call it a linear relation. All right. So and here, this is a equation. This is a equation of a linear relation. So when we have a y and x and y, input variable is always independent variable. So input, and input is usually x. X is independent variable. X is when you draw x-axis and y-axis, x is horizontal variable, right? So x is horizontal variable, so you say horizontal variable is an independent variable. And dependent variable, y value changes depending on x, right? So y value changes depending on x. So this is basically, so therefore, output and y value and vertical variable is a dependent variable, okay? So x is independent and y is dependent. So if you look at this, input is this. And depending on this value, we found the output value. So therefore, output is a dependent variable and input is an independent variable. Make sense, everyone? Let's move on. Example 1. The table of values shows the cost of renting DVDs at an online store. So number of DVD. So depending on the number of DVD, the cost changes, right? The cost depends on the number of DVD. So this is dependent variable and this is independent variable. Okay, remember that. So this is input and this is output values. Okay, graph the data. Does it make sense to join the point on the graph? Explain. Okay, here, let's graph it first. If it is one DVD, the cost is $3.50. 2 DVD, $7. 3 DVD, $10.50. 4 DVD, $14. So I want you to do this. 5 DVD, $17.5. It will be somewhere over here. Okay? So we graph the point. We plotted the points. And does it make sense to join the graph? Would you join the graph? Okay, everyone, can we rent a half DVD? For example, can we put a point in between like 0 and 1? If we can rent a half DVD, how much is it? Half DVD will be like $1.75. So can we put a point here? Or can we rent like 1.5 DVD? And if we can rent a 1.5 DVD, that will be $5.25. Can we put a point here? Does it make sense? Can we rent a decimal number of DVD? If we can put more points in between 2 points. But it does not make sense to rent a half DVD or like 1.7 DVD or 1.8 DVD. So we cannot put any more points other than the whole number points. So it does not make sense to join the points. If we join the points, that means there are lots of more, like infinitely many points in between 2 points. But we cannot put any more points other than whole number points. Therefore, we do not join the point. Make sense, everyone? If you do not join the graph, that's called discrete data. Okay? So, graph the data. Does it make sense to join the graph? No. We cannot rent a half DVD. There is no point in between 2 points. Okay, there's no point in between 2 points. Therefore, we do not join the point. And that's called discrete data. Usually, countable data are discrete data. So you can count the DVD 1, 2, 3, 4, 5. So DVD, number of DVD is countable. That is discrete data. Is the relation linear? Yes, it is. Every time the number of DVD increased by 1, this is increased by 3.5. Therefore, it is a linear relation. So every time this is increased by 1, increased by 3.5, increased by 1, increased by 3.5. Constant rate of change in both variable. So yes, constant rate of change in both variable. Next, find an equation to describe the pattern. So everyone, again, this is the independent variable and dependent variable. The equation always starts with dependent variable and write down independent variable here. Okay, you need two numbers. One number multiply to independent variable, added to the independent variable. What you have to look at is one number this is increased by. 350. So you have to write down 350 here in the first blank. Okay? 350, you can omit 0. 350 times D plus something. You should figure this out. What number do you have to add to get C? So let's test it using the first line. So if you plug in 1, you should get 3.50. What number do you need to add here? Nothing, right? You don't have to add any number. 0. This is 0. So the equation will be C equals 3.5D. You can omit multiplication. C equals 3.5D. Okay? Use the table to describe the pattern in the rental cost. How is this pattern shown in the graph? Okay, you say you're gonna describe it. So every time the number of DVD rented increased by 1, the cost is increased by 3.50. And how is this pattern shown in the graph? Linear. Okay, so it shows a linear pattern. So linear pattern, straight line. Okay, so here we're gonna learn about discrete data and continuous data. So discrete data is counted, is countable. So this one is a discrete data. You did not join the graph. I mean, you did not join the point. So this is a discrete data. Number of DVD is countable. So discrete data is countable. So examples will be number of students. Number of students is countable. You cannot have like 1.7 students. Number of cars, countable. You cannot have like 0.6 car, right? Number of DVD, same thing, it's countable. So discrete data is counted. Points are plotted on the graph with no line connecting the point. So you do not join the point. So the graph will appear as a series of dots. Okay, so example, number of students present in class each day. So Monday, so say I have 12 students, but Tuesday I cannot have like 20.7 students, right? You cannot have half student. So therefore, you do not join the point. Data is countable. So that's called discrete data. Continuous data. Continuous data is measurable. For example, height, you can have decimal points. For example, if a student's height is 172 centimeter, another student's height can be like 181.7 centimeter, right? So heights, it can have decimal points, weight as well, temperature as well. You don't have to count it, you measure it. Therefore, you can have decimal points. Continuous data. Points are connected by a line. So example, those weighed during the first week of lifetime. So here, first week of lifetime. So day 1, day 2, day 3, day 4. Say it was like a 0.5 kilogram. Becomes like 0.6. When it was born, 0.5, 0.6, 0.7, 9, 1 kilogram. You can connect the points. You can join the points because if it is like half day, the weight is still increasing, right? If it is like a 1.5 day, the weight is still increasing, and that will be somewhere in between those 2 points. Is that right? So that's called continuous data, and you join the points. Make sense, everyone? Next, example 2. The cost for a rental car, a car rental, is $60 plus $20 for every 100 kilometer driven. The independent variable is the distance driven, and the dependent variable is the cost. Let's fill in the table, plot the graph, and identify if this is a linear relation. So 0 distance, this is 0 kilometer, so that's $60, and every 100 kilometer it's increased by 20. So it's 80, 100, 120, 140. Okay, so there's no scale here, so you're going to make the scale by yourself. So say this is independent variable, and this is dependent variable because the cost depends on the distance. So independent variable is horizontal variable. So I'm going to start from 0, increased by 50, 300, 400, 500. So when you decide the scale, it should have the same increment every time it's increased by the same 1 unit. The increment should be same. So this time the increment is 50. It's increased by 50 every unit, right? So every 2 units it's increased by 100 kilometer. And distance, starting from 0, let's do 20, 40. So increment, I would decide the increment 20. So 40, 80, 120, and 160. So the increment, every unit is increased by 20. So 2 units increased by 40. Okay. So if it is 0, the cost is 60. 60 is here. When it's 100, the cost is 80. 200, the cost is 100. 300, the cost is 120. 400, the cost is 140. And it's not part of the table, but if it is 500, it's going to be $160. So we plotted. Is this a linear relation? Yes, it is. It shows a straight line. But does it make sense to join the graph? So everyone, is this measurable data or countable data? Cost and distance. It's measurable data. So if it is a reasonable rental car company, they will charge you depending on the distance. So say you drive 50 kilometers, then they will charge you $70, right? So the point will be plotted here. And if you drive 150 kilometers, they will charge you $110. The point will be placed here. So if you put all the points in between 2 points, that will form a linear line. So it makes sense to join the points. So this is continuous data. And everyone, since it has a constant rate of change every time the distance increased by 100, the cost increased by 20, and the graph is a straight line, it's a linear relation. So yes, fill in the graph, plot the graph, and identify if it is a linear relation. Yes, it is a linear relation because it has constant rate of change. So therefore, it is a linear relation. Okay. And everyone, we can find the rate of change using change in dependent variable and change in independent variable. So if you look at this, the distance is increased by 100, 100, 100, 100. And the cost is increased by 20 and 20, 20, right? So change in dependent variable is 20 and change in independent variable is 100. So 20 over 100 is 1 over 5. Is that right? So this is the rate of change. So when you make an equation here, so we first decide the variable. So I'm going to use D for the distance, C for the cost. So you start with C here. Start with C and write down D. You have 2 blanks here. And in front of D, you have to write the rate of change. The rate of change is 1 over 5. You don't write 20 because the distance is 100. The independent variable is increased by 100. So before this was increased by 1. So it was okay to use this number itself because the rate of change is 3.5 over 1. 3.5 over 1 is just 3.5. So we use the 3.5 to make an equation. But we actually need to use the rate of change. And the rate of change, you find the rate of change using this formula. Change in dependent variable over independent variable, which is 20 over 100. If you reduce it, it is 1 over 5. And you write down 1 over 5 over here. After that, you're going to find this number. That's actually initial amount here. If it is 0, the initial cost is $60. So 0 kilometer driven, you still have to pay $60. So you write 60 here. So we can also say the rate of change, numerical coefficient. So everyone, what are coefficients? Coefficients are the number attaching to the variable. So this is a numerical coefficient. And the 60, this is initial value. Another word, it's a starting value. So your workbook uses those terms, starting value and numerical coefficients, okay? Okay, example 3. Which of these are continuous and which are discrete? State the independent and dependent variable, okay? So I said continuous variables are measurable and discrete variables are countable. So volume, time, are they measurable or countable? They're measurable, right? So it is a continuous data. Volume is dependent variable and time is independent variable because volume changes depending on time, right? And the number of students attended class each day. So I want you to read B, C, D, E and solve this by yourself first. Go ahead, everyone. All right, number of students. Is that countable or measurable? It is countable, right? So it's discrete. And the number of students, this is dependent variable. And each day, this is an independent variable because the number of students changes each day, and it depending on the day, the number of students changes, right? Speed and time, are they measurable or countable? It's measurable, right? So it's C. Speed is dependent and time is independent. because the speed depends on time. So depending on the time, the speed changes, right? And the weight of a puppy each week, is it dependent or is it continuous or discrete? It is continuous because weight is measurable, not countable. And each week, between week 1 and week 2, the weight still changes. So we should join the points, right? It's a continuous data. The number of green M&M, is it countable or measurable? It is countable, right? So this is discrete data. And I forgot to figure out if this is a dependent or independent. So weight is dependent, and each week is independent. Okay? And the number of green M&M, this is dependent variable. In a bag, well, in each bag, I would say this is in each bag. So this is independent variable. Okay, so let's move on. Number 4, circle linear relation and justify your answer. Write an equation for the linear relation. So x is increased by 1, x is increased by 2, and x is increased by 4. And y increased by 2, 4, and 4. Do you think this is linear relation or not? So let's find the rate of change. What is the rate of change? We have to find a ratio of changing y over changing x. So that is 2 over 1. And this one, 4 over 2. So those are both 2 and 2. Same rate of change. But the last one, 4 over 4. This is 1. So this is not a linear relation. So what about this one? This is increased by 1, 1, 1, and 1, 2, 3. Obviously, it's not a linear relation because 1 over 1 and 2 over 1 and 3 over 1, those are different numbers, right? It's not a constant rate of change. So this is not a linear relation. Okay, look at this. Increased by 2, increased by 2, increased by 2. Y increased by 4, 4, 4. So the rate of change is 4 over 2. Okay? So this is a linear relation because it's the same rate of change, constant rate of change. And the last one, increased by 4, increased by 4, increased by 2, 4, 4, 2. What's the rate of change, everyone? 4 over 4 and 4 over 4, and the last one is 2 over 2. So what's 4 over 4, everyone? 1, 1, and 1. So this is also a linear relation because it's a constant rate of change. So we need to look at the ratio of it. All right? Okay, the first one, 4 over 2, this is the rate of change. We're going to make an equation, y equals blank x plus blank. And I said we need to write down the rate of change here. And we need to figure out this number. So to figure out this number, we can just simply plug 1, 4 or 3, 8 or 5, 12 or 7, 16, any of those 4 points into, just choose one of those 4 points and plug that into x and y. So let's plug 1, 4. 1 and 4. Then we get 4 equals 2 times 1. Timesing is hiding here. 2 times 1 is 2 plus something. What do we write here? That is 2. So the answer is y equals 2x plus 2 is the answer. Okay? And what about this one? The rate of change is 1. So we write down an equation. In the first blank, the numerical coefficient is 1. and we have to figure this out. So I want you to pause the video, figure out the initial value. This is called the initial value. Okay? So go ahead, everyone. All right, did you guys just try it? Let's do it together. So we're gonna use 1, 4. So let's plug 1 into x and 4 into y. Then 4 equals 1 times 1 is 1 plus something. So this number should be 3. All right? So the answer will be y equals 1x plus 3, and we can always omit 1. So this is the answer. All right, everyone, that is it for today. Now I want you to start doing your assignments. Bye-bye.